Hello class, today we're going to talk about naming compounds. Remember that ionic bonds or ionic compounds are between metals and nonmetals, and covalent bonds or covalent compounds are between two nonmetals. Remember, throughout the lesson you will come across learning checks. Please pause the video. When you see a learning check, complete the learning check and then you may press play to resume the video. Let's look at naming ionic compounds. Remember that ionic compounds are between metals and nonmetals. So the first step is to name the metal. The second step is to name the nonmetal. And you drop the ending of the nonmetal and add I. Remember there are no spaces separating the name of the metal and nonmetal. Here are some examples of some common ions. So we have potassium and iodide. You see that we named the metal first, which is potassium. The ending changes from iodine to iodide, IDE. The same with magnesium bromide and aluminum oxide. So let's look at this example. We have Mg3NN2. So the first step is to identify the cation. Remember, cations are positive and anions are negative. So in this formula, magnesium is the cation and nitrogen is the anion. So we name the cation first because the cation is the metal. And then we follow with nitrogen, which becomes nitride because we dropped the ending of IGEN and added IDE. Hence, we have the formula name of magnesium nitride. Now you try. Remember, you have to name the metal first, then name the nonmetal. Drop the ending of the nonmetal and add IDE. Let's look at the first example. Remember, first you name the metal and then the nonmetal. So the metal is calcium and the nonmetal is oxygen. Remember, you drop the ending and add IDE. Hence, we have oxide, calcium oxide. Let's do a quick review about finding formulas from charges. Let's take the example of aluminum and sulfur. So aluminum has a charge of 3 plus and sulfur has a charge of 2 minus. Remember, if we crisscross down, we can find the formula. So aluminum now has 2 and sulfur now has 3. Now, in this learning check, I want you to do the crisscross down to find the formula and also name the compound. So looking at the example that we just did, we can name this compound aluminum sulfide. Now remember, with transition elements, we can't find the charges from the group numbers because they have variable charges. Variable charges mean that the charges of each ion changes, and this happens in transition elements. So metals form 2 or more positive ions except for zinc, silver, and cadmium, which only has 1 ion. With variable charges, we have to name them a little differently. Variable charges uses Roman numerals. The Roman numerals are named after the metal and it identifies the ion charge. For example, cobalt has a variable charge of 2 plus and 3 plus. So if we want to represent cobalt 2 plus, we say cobalt Roman numeral 2 and cobalt 3 plus is cobalt Roman numeral 3. Let's do an example together. Let's take FeCl2. The first step when we're naming variable charges is to identify the cation and the anion. Remember, your cation is your metal. In this case, it is iron. And your nonmetal is chlorine, which turns into chloride because we have to drop the ending and add IDE. Well, This is one step that I didn't show, but here it is. If we have Fe and Cl2, if we crisscross down, we find the formula, but if we crisscross up, we can find the charge. So Fe now has a charge of 2 plus because we know it's a metal, so it has to have a positive charge. And Cl now has a charge of negative 1 because it is a nonmetal, and we know that Fe had 1 as its subscript, so it came up to be a negative 1. And chlorine is a nonmetal, so it has a negative charge. The second step is to name a cation by its element and use a Roman numeral. Being that we found out that the charge is positive 2 by crisscrossing up, we can name it iron 2. Remember, it's the same way as naming ionic compounds. We name the nonmetal, drop the ending, and add IDE. Our fourth step is to put it all together, and we have iron 2 chloride. Here are some more examples of naming variable charges, but let's go back over the crisscross up. Let's look at Fe2O3. If we crisscross up, we can find the charge. So Fe now has a charge of 3 positive, and oxygen now has a charge of 2 minus. I know that Fe has a charge of 3 positive because we crisscross the number up to gain the 3. And since iron is a metal, it has a positive charge. Oxygen crisscrosses up from the 2. It crisscrosses up, and we have a 2. And I know that oxygen is a nonmetal, so it has a negative charge. Oxygen also is a representative element in group 6A, so we know that it also has a negative 2 charge. Why don't you practice crisscrossing up with copper phosphide and lead sulfide and see if you can come up with the charges? You can also write a formula from the name. Iron symbol is Fe. The Roman numeral 3 means that iron has a charge of 3. And the oxide is oxygen. So if we put it all together, if we say that iron has a charge of plus 3, and we have oxygen, which we know has a charge of 2 minus, remember we can crisscross down to find the formula. So we have Fe2O3. Okay, here's a learning check for you to try to do on your own. Try to name CuO. Remember, your first step is to determine the cation and anion. The cation is positive, which is a metal, and your anion is negative, which is a nonmetal. So we have copper as our metal and oxygen as our nonmetal. The second step is to add your Roman numerals. Since copper has a charge of positive 2, we have copper Roman numeral 2. Remember, we have oxygen, drop the ending of oxygen and add IDE, and hence we have copper 2 oxide. Now I'm going to let you try this learning check. Whenever you see a learning check in the videos, remember to press pause before revealing the answer. So, copper, you have copper and nitrogen. Well, copper, being that we have a Roman numeral 1, has a positive 1. I know it's positive because it's a Roman numeral 1 and it's a cation. And nitride has a 3 minus charge because it's in group 5A. So if we crisscross down, we have copper 3, nitrogen 1. Okay, now we're going to talk about naming covalent compounds. Remember, covalent compounds are between two nonmetals. So you're going to name the first nonmetal, and then you're going to name the second nonmetal. The second nonmetal is going to end in I, just like when we're naming ionic compounds. But with covalent compounds, we use prefixes to indicate the number of atoms present in each element. So here are the prefixes that we use when we're naming covalent compounds. The rule with mono is that you can only use mono for the second nonmetal. You do not use mono for the first nonmetal. Here's an example when you do not use mono for the first nonmetal. So for instance, we have carbon disulfide. As you can see, we do not put mono in front of the carbon. So let's work through this covalent compound. Sulfur, oxygen 2. So we name sulfur, oxygen, there's 1 sulfur, so we do not put mono, but we have oxygen, and oxygen has 2 atoms, so we use di. So we name the second nonmetal, which is oxygen. We drop the ending and add I, and we add di for the prefixes because there's 2 oxygens. So we have sulfur dioxide. Now here's your opportunity to try this one on your own. P2O5. So first we name the first nonmetal, which is phosphorus. There's 2 of them, so we use the prefix di. Then we name the second nonmetal, which is oxygen, and there's 5 of them, so we use penta. We drop the ending of oxygen, and we have oxide, hence we have pentaoxide as our name. Now I'm going to give you the opportunity to do this learning check. If you chose C for number 1 and A for number 2, you are correct. If I were to give you a name, you should be able to determine the formula. So let's look at sulfur hexafluoride. Sulfur, being that there's no prefix, it's understood to be 1. And hexa is 6. So we have sulfur, which has 1, and fluorine, which has 6. So we have SF6. Now, here's a learning check for you to try on your own. Nitrogen has 2, so we have di. Oxygen has 3, hence tri. So we have a formula of N2O3. Now, here's your chance to do a learning check. It's a recap of all of the things we have done so far. Make sure you determine if the compound is ionic, covalent, would it use Roman numerals or prefixes? If you got these answers, you are correct. Great job. Now here's another learning check to go from names to formulas. I'll give you a couple of minutes to work on them. If you got these answers, you are correct. Great job. Now be mindful, you first have to make sure if it's ionic, covalent, does it use Roman numerals or prefixes. This ends the lessons of naming compounds.